So you have to do this one by hand, which is a summation notation plugging in terms 1 through 7 minus a summation notation plugging in terms 0 through 6. So R is 2, which I don't know why they just didn't put 2 there. Not really sure. But if we start this problem and kind of wrap our head around what's happening, when you plug in a 1, you're going to get A times 2 to the first power, right? K equals 1, so I'm plugging 1 in for K. Plus, then I have to plug in a 2. So that's A times 2 to the second power. Plus, I have to plug in a 3, and so on, all the way up to plugging in a 7, A times 2 to the 7th power. And that's the first summation notation. Minus. I'm plugging in on the second one anywhere from 0 to 6. So A times 2 to the 0 power plus A times 2 to the first plus A times 2 to the second, all the way up until 6. So the idea here is to find a quicker way, right? That's going to take a while. That would be plugging in 7 terms, 7 more terms, and doing, that's 14 plugins, that's a lot. So they're hoping you'll pick up on the pattern because it's the same function in both cases. This one's doing 1 to 7, this one's doing 0 to 6. So in this set of brackets, you have A2 to the first minus A2 to the first. So they both include plugging in a 1, so that'll cancel. They both include plugging in a 2, A2 squared, A2 squared. So A2 squared minus A2 squared, gone. They both include plugging in a 3, a 4, a 5, and a 6 as well. So everything 1 through 6 is going to cancel. The only thing on this first one that won't cancel is the 7 plug-in, so A times 2 to the 7th will be all you have left, minus, and the only thing over here is the 0. So it's A times 2 to the 7th, which is 128A, minus A times 2 to the 0, which is A times 1, so just minus A. And 120A minus 1A is 127A. That makes sense? And they just throw an A in there so you can't do it on your calculator. Yeah. You did every single term. You did a series. Oh, smart. So she knows it's a series, or that it's a geometric series, because your base is 2, because it's exponential in nature. So A2 to the nth power, pretty much is what we have. So she did her series on this one through 7 terms. Your first term on this one was, when you plug in a 1, just 2A, right? Yeah, that would work. So you got that series total in terms of A, minus got that series total in terms of A, and so you turned it into a series. Fine, it works. Not all summation notation ones are doable with a series because they might not be geometric, but this one was. So you could use a series. Nice. Never thought about that one that way. Good job. Might be a little more work. No? You didn't mind it? I think if you saw the pattern, like I wrote out a lot more than what I would have done. I would have realized probably in my head, 1 to 7, 0 to 6, the 1 through 6s are going to cancel. I wrote it out more so you guys could see it actually kind of happen, but so I just never thought of it that way. It's great. Any other questions? Oh wait, we got one more 10, right? All right. This was like the one on the notes that we didn't get to on the arithmetic sequence day, but the very next day I started by going over the homework problem that was just like this. So I know you handed those in, so you can't really look back. So given this is an arithmetic sequence, whatever we add to get from term 1 to term 2 has to be the same as whatever we add to get from term 2 to term 3. So if you look from here to here, and by the way, add means add or subtract. So to get from 2x plus 1 to x plus 11, we subtracted an x and added 10. That's the first common difference. The second difference, we added a 3x and subtracted 6. Well, wait, Mrs. Rahill, you said that they had to be the same, and clearly they're not the same. We can, yes, they are the same. We just have to find the x value, right? They are, you know that they have to be the same. They're not looking exactly the same because they're written in terms of a variable, and we don't know the value of that variable yet. But they are the same, so set them equal to each other. They have to be in order to be an arithmetic. And when you solve that, you get x equals 4. And if x equals 4, negative 4 plus 10 is really 6. And when you plug in 4 here, 12 minus 6 is 6. So yes, the common difference is plus 6, plus 6, plus 6, plus 6. The terms themselves, if x is 4, that's a 9. That's a 15. That's a 21. And you can even more clearly see the plus 6 happening. Okay? If they want the 15th term, a sub 15 equals, you're using your sequence formula if they're asking for a specific term number. So that's the top one over here. A sub 1 was 9. Plus 15 minus 1 times the common difference of 6. That gets you your 15th term. Versus C asks you for the sum of the first 30. That sum indicates that it is a series question. Still arithmetic, so it's this formula up here on the whiteboard. That's the only one that you have to memorize that you will not be given. So S sub 30, to find the sum of the first 30 terms, that's 30 over 2. A sub 1 was 9, plus A sub 30. Well, I don't know the 30th term. This is when we have to go back to the sequence and find it. A sub 30 equals the first term 9, plus 30 minus 1 times 6. Once you get that number, plug it in here, and then crunch those numbers, and you'll have the series total. Good? Okay. All right, take out your notes. We didn't start these at all yesterday, correct? Okay. Write an explicit formula, okay? One thing I want to point out in general is that there are three ways of writing a sequence formula. You've got arithmetic, a geometric, and a recursive. This, more specifically, these are your explicit ones. And these are the ones that you will be given. Those are explicit. They allow you to jump to the 50th term without doing all the terms leading up to it as well. Whereas a recursive might be an arithmetic recursive, might be a geometric recursive, or might be either. Not every sequence has to be arithmetic or geometric. Those are just the most common ones that we have follow-up formulas for. If your recursive formula is arithmetic, it will be the previous term plus the common difference. And then if asked, you would then be able to know how to turn it into an explicit. Or if it's a recursive previous term times some number, now that is something that could be turned into an explicit if you want. But like I said, not everything is arithmetic or geometric. We just looked at one on the first question that someone asked that was neither. So the one that was this, times 2 to the nth power. That's not arithmetic or geometric. Because maybe you want to say geometric because you're multiplying, but you're not multiplying by the same constant every single time. You're multiplying by something different every time based on what the return you're on. So, to some, people want to know if they had to memorize this. Well, I guess yes, but I don't really see it as something to memorize. You obviously just need to know how to write a recursive formula, but you don't really, all you have to know is to write it, you have to write it with a sub n minus 1 term and say what you're doing to it. What are you doing to that page, turning off what you're starting with? Okay? So these are sequences, and so is this one. This one is specifically arithmetic, this one is specifically geometric. Depending on what you do the previous term, this one could be arithmetic, could be geometric, could be geometric. There is no series for things that are neither. Okay? If it's something like that last one, like times 2 to the n, that's not arithmetic, not geometric, then they're not going to ask you to come up with the sum of the first 100 terms. That would be ridiculous. Okay? If you want a shortcut to that. But if it's strictly geometric, then you can use the geometric series and then other geometric sequence forms, and that is doable because you have a series shortcut for that. All right, that's all I'll say about that. So write an explicit formula. So if I'm writing an explicit, then this must be either arithmetic or geometric. For the nth term of the recursively defined sequence below. So they gave me a sequence. They told me the first term is x plus 1. And any nth term we're going to get by taking the previous term and multiplying it by x. So question number 1. Is it arithmetic or geometric? Geometric, because we're multiplying by what? X, over and over and over again. So your rate equals x. That's weird, right? But leave it to the Common Core. That's what they do. You're used to seeing rate as a number all the time. They make it x. So to write your explicit formula, we know it's geometric, so we're doing a sub n equals. A sub 1 is x plus 1. It's a binomial, so keep it in parentheses. Times r is x to the n minus 1 power. That's all you can do. You can't multiply this because this has its own exponent to worry about. So that's it. That's the explicit formula. You've plugged in your first term, you've plugged in your r, that's all you can do. Part B says, for what values of x would a sub n equal 0? So when will a sub n equal 0? What would x have to be? And there's two answers. What could x be that would make this whole thing equal 0? Think about teeing it up. It's not a quadratic necessarily, but at the same time, we have something times something else that's supposed to equal 0. If either one of these equals 0, then the job is done. So what would x have to equal here if x plus 1 needed to be 0? Negative 1. And what would x have to be here if this whole thing was to equal 0? What would x, which is 1 to any power is 1. 0 to any power is 0. So if x was 0, that would also be a solution. Look it up. In 2 and 3, I threw these on here because I wanted you to remember that, yes, you're given these explicit formulas, but in an arithmetic sequence, if you're given the 11th and the 23rd, well, this isn't so helpful. So what is it that we did to this sequence that made it more useful when we weren't given the first term, Maggie? Yes. The 1's turn into k's. So a sub n equals a sub k plus n minus k times d. That just makes it more useful. So from this a sub 23 equaling negative 19, a sub n would be negative 19. That's the term. And n itself is the 23rd term. From the a sub 11 equaling 5, a sub k is your 5. The k value is actually the 11th term. So if I plug in all those numbers, a sub n is negative 19 equals a sub k is 5 plus n minus k is 23 minus 11 times the common difference that I don't know. Obviously, those plugins allow me to solve for d. So if I subtract 5, I get negative 24 equals, this is 12d, so d equals negative 2. That's great. I now know d. I still need a sub 1. So now I can go back to that formula and try to find a sub 1. A sub n can still be negative 19. A sub 1 is what I'm looking for, plus n is 23 minus 1 times, and we just found out that d was negative 2. So now that allows me to solve for a sub 1. 22 times negative 2 is negative 44, so if I add 44 to both sides, a sub 1 equals 25. And finally, I can do what they asked. Find a sub 100. So a sub 100 is going to equal my first term, which was 25, plus 100 minus 1 times negative 2. And that will give me my 100th term. A maze of formulas, essentially. I just used the same sequence formula really 3 times over. Okay? And number 3 is the same idea. I'm given the 3rd term and the 12th term. So again, I know I'm given the sequence formula, but the sequence formula they give me is always conducive to the 1st term. If I don't have the 1st term, just change those 1s to k's. And then a sub n will be the 1.2288, and n will be 12. A sub k will be 120, and k will be 3, because that's the 3rd term. And then same thing, you plug in there, it would allow you to solve for r. Once you know r, you can go back and do it again and solve for the 1st term. And once you know the 1st term and r, then you can find the 5th term. Does this make sense? Any questions so far? Okay. Another example down here of summation notation. Brianna, so your method that worked earlier on that kind of similar looking problem that we had on last night's homework, this wouldn't really fit the bill for that because it's not linear and it's not exponential. So you couldn't do a series here. Right? Sometimes summation notations, you can do a series as a shortcut. If you know it's arithmetic, if you know it's geometric. One way of kind of telling if a shortcut is possible is they'll give you ridiculous numbers. They'll give you plugging in 1 to 100, and obviously no one wants you to do that by hand. You don't have time for that, so there must be a faster way. And in those situations, I encourage you to use the series formulas. Something like this, though, just plugging in from 2 to 4, not that bad. Here, plugging in 0 to 2, not terrible. So if I start by plugging in 2, Mike, what am I plugging 2 in for? I, right. So that's going to be 2x plus 2 times 2 is 4. Plus, now I have to plug in a 3. So that's 3x plus what? If I'm plugging in a 3 for I, 3x plus 6. And then a 4. That's 4x plus 8. That's my first summation notation. Minus, and they switched the formulas up here, so there's also no like overlap that you can kind of quicken things up with. This is a totally different formula. I got to plug in a 0. What's 2 to the 0 power? 1, so that's just 1x minus 3. Plus, I have to plug in a 1. 2 to the first power is 2x minus 3. And then if I plug in a 2, 2 squared is 4x minus 3. And then because there's binomials within the brackets, my recommendation would be to add all this up first. So 4, 7, 9x's plus 18 in my first set of brackets minus 4, 5, 6, 7x's minus 9, and then do the distribution of the negative. 9x minus 7x is 2x, 18 minus a negative 9 is 27. So they really want you to understand how summation notation works by hand. So they force you to do it by hand by throwing all those x's in there. Making series, not a possibility. Making using your calculator, not a possibility. Okay. This one is, again, these are all, when I do your review sheets and your tests, they're all Common Core questions. Same topics, but you've never seen one like this before in the sense that it's never been phrased exactly this way. The concept that this one tests about, we have looked at. You'll see it when we get there. So the 8th term is 64, and the 10th term is 100. So there's the 8th term. Then we're missing some 9th term, and the 10th term is 100. If the sequence is either arithmetic or geometric, the 9th term cannot be which of the following. So of the 4 answers there, 3 of them are possibilities. And that seems weird because how is that? We've got an arithmetic sequence, so if we treat it as arithmetic, then there would be a specific answer. And if we treat it as geometric, there would be our second answer. So why is it that we have 3 that are possibly correct? So let's start with arithmetic. If we were doing arithmetic, you could call this a sub 8 and this a sub 10, and you could go through the formulas, but these terms are so close, we could just kind of think about it. You have to take 64 and you have to add some d value to get here, and then you have to add that same d value again to get to 100. So essentially what we're doing is we're taking 64, we're adding d on twice, and it's supposed to land us at 100. That's really what your formula does for you anyway. We just kind of did it more logically here. Mitch, you kept saying just take the difference and divide it in half, right? Yeah. All that will work. So 2d equals 36, so d equals 18. So if d is 18, what would that number be? 82. So 82 is a possibility. Check. We're looking for which one cannot be. So then, similarly with geometric, we're multiplying by r, and then multiplying it by r again. So Mitch, all of a sudden what you wanted to do works for arithmetic, but doesn't really work here. I don't think. Right? Yeah, it's a little bit different when it's a multiplier. You could go back to your geometric sequence, and you've got a sub 8, and you've got a sub 10, and you could use all of those. But again, because it's a short jump, I think it can make sense to write it out logically as well. You're starting at 64. You're multiplying by r, and then you're going to multiply by r a second time, and you should get 100. So in other words, that's 64r squared equals 100. So how do I solve this? What do I do first to both sides? Yep, divide by 64, which I'm just going to leave 100 over 64. Then what? Okay, then what? R equals. Well done, Michael Lang. This is going to be 10/8, which reduces to 5/4, or if you have your calculator, 1.25. So that's the reason for 2 options. Because if you use a multiplier of 1.25, 64 times 1.25 will get you to 80, and then times another 1.25 just to confirm for you will get you to 100. So 80 is a possibility. But also, if you multiply by negative 1.25, that gets you to negative 80, and multiplying by that negative 1.25 again still gets you to 100. So it's that concept of every other term is going to be positive. The middle term could be positive, could be negative, depending on if your R is positive or negative. And if your R is a negative number, they will alternate. Positive number, negative number, positive number, negative number. So negative 80 is also a possibility, and that is the only one that is not. Okay? Tricky. All right, last one. Your good friend Elena is deciding to run the Buffalo Half Marathon. Oh, Buffalo got a shout out. I pulled this right off of Regent, so Buffalo got a shout out. She researched training plans on the internet and is looking at 2 possible plans. Jillian's 12-week plan. Jillian's the dot. Look at your key. And Josh's 14. Josh is the X's. The number of miles run per week for each plan is plotted below. So just to kind of make sense of this, in week 1, Jillian is going to have run 10 miles. So that's like a little over a mile a day. Yes? In week 2, Jillian will have run 11 miles. Week 3, 12 miles. So her pattern's pretty obvious, right? His pattern is week 1, he's running 21 miles. So that's like 3 per day. Yes? Week 2, he's running 22 miles. Then week 3, he goes back to 21 miles, and then he goes up to 22 and up to 23. And then he gives himself a break and goes backwards. And then works his way up a little bit further and comes back 1. Do you follow his pattern? Okay? Which one is arithmetic and why? What? Jillian's? Why? How do you know? Go ahead, Mitch. Take the floor. And what is that consistent amount? Right, yeah. Just the more specific you can do an explanation. Jillian's, because, and that's one way. I'm not going to make you write it. We're just talking this through. Jillian's because you're adding a consistent amount every week. Plus 1, plus 1, plus 1. How else, what other reason could you have given from looking at the graph? Maggie. Okay, but here's something else. If someone else did this pattern, this is always going up too. Linear is more the takeaway. Linear. So because it's linear in the graph, you would say linears or arithmetic, so Jillian's. Okay, either one of those explanations, whether you come from the definition perspective like Mitch did, or if you come from the visual perspective. So now it wants us to write a recursive definition to represent the number of miles run each week for the duration of the plan you chose. For Jillian's plan, essentially. We chose Jillian's. So what would this recursive look like? Christina, I want you to take a stab at it. So my recursives are right up here to the left. You see them? Okay. You have to have 2 equations. So what would your A sub n1 look like? What does Jillian do to the term before? Adds how much to it? 1. So what would that look like? Perfect. And the other part? Good. Okay? So that's recursive. And you're done. To be honest, I don't know why they wanted a recursive and not an explicit, but they said recursive, they got recursive. Explicits are just usually more helpful. Jillian's plan has an alternative if Elena wanted to train instead for a full marathon. Week 1 would start at 13 miles. A sub 1 would be 13. And follow the same pattern. So common difference would still be 1. Yes? But it would continue for 14 weeks. So n would be 14. Now they're saying write an explicit formula to represent the number of miles run each week for the marathon. Explicit means sequence. So A sub n equals, what's my A sub 1? 13 plus n minus 1 times 1. So simplest form means just distribute and combine. So 13 plus n minus 1, because multiplying that 1 through doesn't change much. And you get n plus 12. I'm actually more surprised that they didn't ask you, because the 14 is kind of negligible, right? We never even used it. I'm a little surprised they didn't ask you, how many miles total would she have run in this training program? That would have been S sub 14, right? And then you would have done 14 over 2. A sub 1 is 13 plus A sub n we would have to figure out, which is fine. We'd go back here and figure out in the 14th week, 14 plus 12 is 26, so she ran 26 that last week alone. And so that would give you 7, 26, 36, 39. 7 times 39, 273. That doesn't sound fun. Who's a runner? Anybody like to go for runs? I do. Like that serious of a runner? Has anyone in here ever done a half marathon? 13.1 miles. Has anyone ever run the turkey trot? It's pretty good. And not stopped. All right. I wanted to talk about one more thing here. Oh, I don't know if you want to miss this. Okay, go ahead. All right. This was the first question on your homework, which, in hindsight, I wish I had given you the homework as a practice take-home test and not given you the answers and then just thrown the answers at you at the beginning of class, and I bet there would have been a lot more questions. Because I think with the answers at the bottom, and I don't think this is dishonest in any way, I think sometimes we look at the answer and we convince ourselves that we understand where it comes from, and the connections are a little bit loose, okay? So, with that in mind, I think a lot of you would have gotten this wrong, and we would have had to have addressed it. So I'll address why I thought it's tricky. So Kristen wants to increase her running endurance. According to experts, a gradual mileage increase of 10%. So right away, I know it's geometric. Geometrics increase by percentages. So what would R be? What would be the multiplier to get me from one term to the next term? 1.10. If Kristen runs 8 miles in week 1, so A sub 1 is 8, which expression can help her find the total, that tells me series, the total number of miles she will have run over the course of her 6 weeks, so that's N is 6. So if this was an open response, I would do the series through 6 terms. And it's geometric, so A sub 1 is 8 minus 8 times 1.10 to the nth power, which is 6, all over 1 minus 1.10. If it was open response. So that's clearly where 3 and 4 were going with their options. They use the series formula. Do you see it? Okay? But both are wrong in the sense that your denominator should be negative 0.10, not 0.90. And on this one, the denominator is an issue, and the ratio, the rate they're using is 0.10 as opposed to 1.10. So they didn't do it with a series. They expressed it with summation notation. Okay? So they have 2 formulas that look virtually identical. First term, or 8 is the number out in front, 1.10 is your common ratio. One goes from 1 to 6, and the other goes from 1 to 6 as well. So that's all the same. The only difference is one uses n, one uses n minus 1. So let's think about this. The first term, when we plug in the starting number, when we plug in a 1, what are we supposed to get? How much does she run the first week? We're supposed to get 8. So if you plug in 1, 1 minus 1 is 0. Anything to the 0 power is 1. 8 times 1 is 8. So this one does give you 8. The second one, if you plug in 1, will give you 8 times 1.10. So it's starting that first week already over 8. Do you follow? Assuming that we can make this correct, what would we have to change these numbers to? 0, 2, 5. Yes. Okay? And then that 1 would have been okay. So I just thought that one was a little tricky. Okay, couple things for you. I have in the past given a quiz on series. I'm not giving you this because your test is obviously tomorrow. So I'm not giving this to you as a quiz. I'm giving it to you as homework and as a practice. Okay? And series are good because for a lot of series you have to go back and use the sequence. So it should be all encompassing as far as practicing everything. Does that make sense? So this is your homework for tomorrow. And I also have your arithmetic sequence. Not arithmetic. Arithmetic and sequence. Did I give that to you?
What? Probably.
If you didn't get back the sequence quiz, I have it. I know I went over them all. I went over it. Honestly, I haven't addressed that yet, so we'll just hold off.
Can you look at number 2?
Hey, Brady. Yes.
Sure, I'll be your man.